Good afternoon, ladies and gentlemen. Thank you for joining us this afternoon. This afternoon we're going to present to you a little bit about the company CMA and how design of media influences the economics of printing and recyclability, and how if you use clever design in media you can actually improve printing qualities and also help the environment. So, as with everything in life, great design follows functionality. And one of the things that we try and do is look at some problems in the marketplace, come up with some solutions, and as you can see by the slide here, it's all great coming up with a great design, but you then have to implement it and make it work in the real term, which is where people like Pierre-Alain, who's in charge of our nanoscience and our development of media, fits in, because otherwise salespeople come up with concepts that you can't actually deliver. Now, one of the things we have to look at when you talk about the environment and you talk about recyclability is how you develop media, and a lot of people forget that what you're printing on is actually a color as well. So we get worked up in the world of color management, and we talk about color gamuts, and we talk about how we're going to print something and if it's recyclable and what we do with it. But a lot of people forget that what you're actually printing on actually has a massive impact on the final result. So we take substrates, medias, and paper actually as a fifth color, and the effect that those compounds within that product do have a massive impact on what you actually see on the final print. You've quite often seen, if you see a newsprint, you see a very grey, grainy image, and then you can print the same image on a high, bright, white photographic paper, and you'll see completely different results. So this afternoon's presentation, we want to talk a little bit about CMA, who we are, where we've come from, some challenges that we see in the marketplace, how we developed environmentally friendly solutions for some of our clients, the perfect tran that we launched at the show, some ink-saving solutions, and then inside the media designers, what goes on to a coating. Most people think an inkjet coating is something that's fairly simple and fairly easy, but there's a lot of science involved in that, and Professor Pierre-Alain has been in the industry for over 30 years developing such coatings and was the brains behind a nano-solvent coating, which you'll go into later on. Okay, so CMA. Most people don't know we exist. We were created in 2006, and we're basically a group of color management people. We have 5 locations throughout the world, and we're a truly global business. We were part of Ilford Imaging. We were purchased by them in 2013, and then more recently, after the demise of the company, we took ourselves back into private ownership, and we've carried on with some of the work and some of the technologies that we had been developing with Ilford. We work in numerous different fields within the industry: color management. We work in sign and display. We have a range of different solutions in proofing. And we also have a development division in Switzerland which works on nano coatings and nanotechnology. We're also members of numerous different bodies, and we're certified globally as well. And one of the important things that we're very proud of when it comes back to the environment is we actually plant one tree for every single roll of paper or media that we sell globally. Okay, so what's happening in the world at the moment? You're seeing an awful lot of with the latest printing technologies, massive diversification in media and printing. You see latex, you see UV, you're seeing the memjet technology come into the world. And so what we have to try and do as media suppliers is keep track of that technology and also balance environmental printability and try and basically manage that color gamut, which is changing massively. And so one of the things that we're trying to do is balance sustainability, printability, quality, and basically cover all of those angles and deliver the results that we need for our customers. So one of the things that happened with us, one of our brands came to us numerous years ago and said to us, we're using a photographic process. What can you do? What can you develop to help us generate and manufacture a sustainable and also recyclable product instead of using the photographic process that they're using today? And so this major brand started and asked us to do this, and it's taken about 5 years to get this product correct, because the photographic business and the photographic market is very, very precise. It's massively high color gamuts. The quality levels are really, really high. But the big problem that we had with the Duratran was the fact that you couldn't recycle it. So we spent 5 years into R&D. We finally created the product, and we launched it last month, and we've actually profiled it here. And so we have developed the first fully recyclable, high quality alternative to a Duratran using latex printing. And we chose the latex printing because of its environmental credentials. And so basically we've created a product that looks and feels just like a Duratran. And I'm going to ask Pierre-Alain to talk to you a bit more about the journey we took in developing the perfect Tran.
Okay. So by developing the perfect trans, we had to look on several aspects of ecology and on an environmental issue. So the recycling charts was something very important here. So I put some example of recycling charts. We have a look on eco-friendly charts. Also there is different aspects of ecology, what is friendly in this domain of green printing. We had a look also on photographic wastes. With my background, so I was in imaging photographic industry, doing cibachrome development for quite a long time, so I know what kind of problems and toxic with heavy metals, silver contents, even in a photographic process. And everything you have to do for developing eco-friendly photographic paper or photographic inkjet film. When you develop from a scientific point of view, there is maybe there is a demand from the end user. You have to be green, 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 and from the lab you have several solutions. Okay, so from the base you can have get totally away from the vinyl substrates. You can have highly recycled contents of PET bottles in polyester films, and there is always a limit, and the limit is mostly given by the customer. At some point, a recycled film is less good, less transparent, less clean than a freshly made material. So the ecology is really at the end. There is compromises on several things. What is always the case in good supply, that's the FSC. The pulp is always labeled FSC. It's chlorine, absence of chlorine bleaching. It's oxygen bleach, etc., etc. And that has a slight cost and on the customer. Photo base layer is also now because of the energy to make the layer. So the manufacturer may pay great attention to have more concentrated coating solution, less water to evaporate, so easier, lower energy costing manufacturing. And at the end of the process, you have to print the image, and I think people like HP also made a lot of attentions to have reduce the printing energy, which is quite high with thermal inkjet printing. You reduce the ink curing temperature. That means you can cure at lower temperature, lower energy, quicker. But you have to pay attention to adhesion of the ink of the base, the drying speed, stickiness, etc. So at the end, this compromise is quite important. Okay. For you?
So as you can see, that the concept and making a product eco-friendly or to meet the demands of customers is quite complex. It's not just a simple putting a coating on a certain product and saying, great, there you go. So in conjunction with the Perfect Trans, we also had to develop a recyclable paper and also an alternative to self-adhesive vinyl. Now, most people are under the popular misconception that because it's an inkjet paper, you can basically recycle it. You can't. There is PE coatings on inkjet papers, which means that they are not good to recycle. It's not easy to recycle. So we then had to reverse engineer one of our products and make an eco-friendly and recyclable product. And what we tried to do within this is to balance up, as I say, some of the pros and cons between using an RA4 process and using a perfect tran or using the paper. And as you can see, one of the big issues we have at the moment is that Kodak has a particularly strong brand. Even today, some 25 years after the product was developed, the Duratran name is still specified by brands. And that's going to take CMA quite a long time to actually get people to understand what perfect trans is and then its acceptance into the marketplace. One of the major advantages we have is working with someone like Hewlett-Packard. They've developed their new range of latex with their third generation inks, which actually put on a glossy coating on top of the ink, which makes the perfect trans really work well and punch out, and it makes it just like a Duratran. So you have that lovely gloss feeling that you have, so anyone looking at that product can see that it really does look and copy similar to the Kodak Duratran. You can use the product on other printing techniques, but you don't get the same finish and you don't get the same smoothness, and you certainly don't get the same levels of color definition, which is really important. So along with this, when you talk about eco-friendly, you're talking about environmental side of things, it's not just about the materials you use as well. There's software and there's a number of programs we have within our Color Cloud software, which we're also launching at FESPA. And one of our Color Cloud concepts means that in order to manage color content, we can actually work, and we have a program in place with Roland and MacTac, where globally we can get color consistency. Within that global color consistency, to help the print service provider, we also have built-in ink saving. So the profile is made over the cloud. It's downloaded locally to the print service provider's exact machinery, and within there we have ink saving. So when we look at the ecological part of our business, we don't just focus on certain media, we also focus on some of the print techniques that are being used, and we also have some profiling tools which allow us to actually help ink save as well. And we're not talking about ink reduction, we're talking about true ink saving, so there's no loss of image quality. So I've talked a little bit about the glossy side of what we do, but I want to pass over to Pierre-Alain, who's going to go into some more detail about how we look at medias and how we look at layer design, and he can talk about that for a little bit.
Yeah. So, as Mark just mentioned before, so an ink receiving layer is not just simply a piece of something and some chemistry simply on a base, and it has a lot of requirements. And when you design a material, I want to give some indications. So you have to discuss and look and feel the buzz quality. Is that an ecological base, mechanical properties, feeding accuracy. So you need a friction control. The white point is very important for some application. The accuracy is also very important for proofing with below 1 delta E, or maybe in photographic applications 3 is enough. And the quality is very important for professional. And in post-print, you need a large color space. The ink limits, you need to design a really good sponge to take a lot of inks without over-inking, blotchy build-ups, matting or bronzing effect, etc. And the press consistency and the quality. So I will, in the next few minutes, explain what are the factors affecting all that. We think it's just interesting to understand what is behind a simple photo paper or backlit film or trans film, etc., etc. So an inkjet media is usually a complex assembly of 5 to 8 functional layers, and the way it is done depends from manufacturer's technology. Usually 150 to 200 micron ink receiving layer. That's these layers, they are about 25 to 35 microns. That's about 1/4 of air.
Don't take any, I've not got enough left.
Air. So it's very, very thin. So keep this air as a measurement of what is nanotechnology for later. So there is a lot of functional sublayer, and the technology will not go into much detail, but you have a kind of solid sponge which is mostly air and very small channels here, nano-sized channel to absorb very quickly the ink. The base, it's quite important part. There is many functions that you even cannot imagine. The mechanical property, the stiffness, the lay flat. So there is usually this has a tension. You have to counteract with polyethylene construction. The friction, you have to put a friction layer to feed in your printer. And here it's a white resin layer. It's never white, and in traditional photography, it's a lot of titanium dioxide to make a reflection of the light to make the image very, very bright. So the light coming through the image and going back, and that's a kind of amplification factor. So the tint and the white points and where is OBA and or not OBA, it's an important question for the new proofing standard with the FOGRA 51, for example. Up to now, the FOGRA 39 proofing paper had virtually zero OBA. That means they have also had an inherent light stability. And now with new FOGRA coming, 51 or even 52 for uncoated paper, there is a problem of increasing the stability of OBA. The printing performance now it's given by the chemists who design all these layers. And basically here I put 3 layers, one anti-scratch protective layer, which is very important because you see here in a pigment printing that is this top layer, very thin, who interacts with with the layer of dried pigment. The pigment staying on the surface while the inks are penetrating and being fixed below the layer. Okay, so this is basically a gamut making layer, and this is a sponge to suck all the ink vehicles. That's a traditional construction. So printing performance, there is a lot to do with the top layer because you control the ink dot sharpness, reproduction of the size. That is also the reproduction of the gamut. Each time the same density, the surface pigment fixation, and it has optical effects with matting and bronzing and all things you may see. We'll just see that later. And here I just put a little bit of what the chemists have done with the nanotechnology to ensure really good media here. Here you see a bar of 25 nanometer. 25 nanometer is these particles are about 10 nanometers, so the basic. So they are so small that they do not interact with the light's wavelengths. So they are virtually crystal clear. But they have a lot of surface. So 10 nanometer is 10,000 times smaller than the diameter of air. So that is nanotechnology. What you can do with nanotechnology, if you make the layer more clear, so you can have with the same ink printing, with the same setting, with the same rip, you can have more efficiency in optical density. Here with percentage of black ink with optical density. So you can rise to have a better DMX, or you have an HDR photography, high density range photography. Everything in this layer do influence the stability to ozone, especially with dyes, not too much with pigment, and also the feathering, so the ratio of absorption, lateral spreading, or coalescence if the layer is not well designed for the ink. There is a lot of imaging effect. So all the physical chemists and material science are working with that. Here, a few examples of smudge or pigment adhesion with the same ink on different media. You can have the smudge. So you print all this bar, and after 1 minute, you smudge with your finger, and the pigments do not stay on the layer. But here it's an example of well-designed material. It stays on the layer. Okay, differential gloss. You certainly have observed if you print an image with pigments, sometimes you have a glossy area and matte area on a glossy paper, and that's very disturbing for the eye, and doesn't look like a photographic paper, even if you have a glossy photo paper. And it's especially the case here. It is with an old generation of ultrachrome Epson with different material. If you print a lot of green or blue, that tends to decrease the gloss. And if you have yellow beside the blue, you have a massive difference in gloss value. So it's very perturbating. Just by the media design, you can improve to make that the blue bar is already quite glossy, and it has not visibly disturbing image. Stability was also well worked by the chemists. So it was a big theme 10 years ago with the dye ink. Now with pigments, it is a little bit better. Here I've shown a proofing case example in which we measure the yellowing of the base, so that the white points change with several conditions. And one condition is with light exposure or humidity exposure or a combination of light, humid, and temperature. And you see the conclusion here. That's if you buy proofing paper, but you don't see all the work which has been done here. And you can see color change for the same condition between a good proofing paper or some commercial proofing paper which have a factor of 6 in difference. So that's something you have to really trust your supplier. The same thing, not an accelerated test, but a real computer to plate chemical environment. So it's what happened with plasticizer, which you find in the atmosphere of the press room. And here again, there is yellowing, which can change a lot. So, an example of how we develop together with a customer the solution for an offset proofing paper in America.
Yeah, so thanks, Pierre-Alain. So when you look at paper and you look at coatings, when I showed the first slide, when I said we come up with a concept and then it comes back to great design, in sales you come up with a number of different concepts. Can you make this? Can you make that? Go and make it happen. There's quite a lot of science that goes in behind making something work, especially when it comes into inkjet coating layers. When I started talking about the environmental side of things and what we do, and we talked a little bit about the Duratran project we're working on, and talked a little bit about the ink shaving options that we have. One of the projects that we also had is we undertake a rationalization of range. One of our customers in America has 39 proofing products in their range. They are the biggest selling and biggest distributor of offset paper in North America. and consequently they had a massive proofing range. So we took some of their stocks, we rationalized it, and from an eco point of view, we basically reduced their SKUs from what was 39 proofing papers down to just 3 basic proofing papers. And we did that using design, we did that listening to what the customer wanted and trying to make sure that we could mirror some of the coatings to actually hit some of the product points they wanted. So when we look at eco solutions, it's not just about making a cheap media or a different media or recyclable media, it's also looking at someone's range and trying to rationalize it. So, Pierre-Alain, do you want to talk a little bit about how we went through that process?
So when that process, so we jump in a way of the new standards, and with the industry evolving to a FOGRA 51, that means with the new measurements, and you take into account the optical brightener and the fluorescence of the paper. And why was that requested by the industry? It is because I think in the States, more in the States than in Europe, but it's also coming that the stock, the offset paper have a lot of OBA in them, and for the proofing, it was better to have a proof paper which is closer to the target than a FOGRA 39, which is a yellowish, more neutral paper. And here we have selected maybe 10 different suppliers and for the people who are in the business of offset printing, you recognize Soporsets, Williamsburg, McCoy, Stirling, Endurance, or Carolina, typical offset paper in America. And you see on a blue scale here, so the paper are very blue, from -4 and up to -11. And if you want to simulate them with the ISO-FOGRA here, you are very far from that. And the new Graqual standard is closer to them, and also higher in brightness. Okay, and that shows that with a new range of FOGRA 51 paper, you can really simulate along this green line all this paper, which if you take traditional match print Kodak type 3 paper, which is a standard or type 1, along here, you cannot, with the white background printing, simulate all this paper. Okay, so that we come with a range of 2 or 3 paper, which you can simulate all the FOGRA, all the offset paper from America. And this trend is also coming in Europe, and this new standard is being discussed for a long time, and hopefully approved or being approved, finalized this year. Oh, sorry. I think that's the same.
So
same thing.
From where we were in the US and what's happening in Europe, if you're a global print company or you're trying to produce printed matter across the world, you have a number of different standards to hit. So many printers in Europe were struggling with a set of proofs that came out of the US. And what you're going to see with the FOGRA 51, 52 and the Graqual 2013 is the papers are getting slightly bluish, so you're going to get consistency, and you're going to start to see much easier for everyone to start hitting some common colors, and that will help with everything to do with color management and hitting colors on press, reducing waste. So just to wrap up, really, I just wanted to go back through a little bit about CMA and where we sort of operate in the different sectors we operate in. And what I wanted to do is just basically thank you for paying some time and listening to what we had to say. And if you have any questions or anything, please feel free or come and see us after the presentation. Thank you very much.